Right, this is the setup we're going to use to investigate the lens equation. Okay, the lens we've got here is fat in the middle, so that's a convex lens or converging lens. Okay, now that's going to go into the wooden lens holder like that, so that's just going to hold it vertical. Now the object I've got here is quite simply, it's one of those ray boxes. Now I've got a protractor stuck to it because we need to see exactly where the image, which is going to be projected onto the screen, we need to know when that's going to be perfectly in focus. So we're going to be focusing in on the numbers on the protractor. Now I've got the 90 degrees, similar, you should be able to see that. I've got the 90 degrees right in front of the bulb. So that is going to be our object. And that's going to go at this end of the ruler like this. So we've got our object here, we've got our lens here, and we've got our screen here, which we're going to project our image onto. Now, this lens here, this is quite fat in the middle. This is a convex lens with a focal length of about, well, exactly 5 centimeters. So you should remember that because we've got our object further than f, we're going to get a real inverted image, which we're going to pick up on the screen here. Okay, so in terms of in the context of the lens equation, this is our object distance here, this is our image distance here. Okay, now I'm going to call the overall distance between object and image, we're going to call that D, or big D. Okay, so to find out the object distance, that's this distance here, I'm going to read off here, but to find the image distance we need D minus U. Okay, right, to get us started, I'm going to turn on the ray box. Okay, now you should, if I zoom in a little bit, you should be able to see the image is being projected onto the screen. Right, hopefully you can see there it is inverted, so that's a 90 degrees upside down. Okay, now what we're going to do here, we're going to have a range of different values of U and V. Well, the way to do that is I'm going to increase D each time and then position the lens so that we get our image exactly in focus. Okay. Right, so I'm going to start with, okay, that's always good to figure out the range, okay, to figure out the range of values you're going to go for first. So if I just reposition the camera, hopefully you can see we've got the full meter ruler there. Now if I put the screen at the other end, you should be able to see. If I turn off the light here, we can just about make out the image distance, the image projected onto the screen. Okay, so we'll just change the position on that slightly. Now, as you can see, upside down, okay, but it's slightly out of focus. Now, to get that exactly in focus, I need to move the position of the lens. Okay? Now, moving the lens away from the object takes it right out of focus. Okay? So we need to go towards the object. So keep going, keep going, keep going, keep going, keep going, keep going. Now, if I go too far, it's out of focus. So we're looking for a nice, crisp image, which I think is about there. Okay, so if we zoom in, hopefully we can see there a nice, crisp, and there's good. image projected onto the screen. Okay, now if I go the other way, if I go right to the other end, right, let's have D as 20 centimeters, okay, or 200 millimeters. Let's just zoom in a little bit. We're not getting an image at all, so we need to move the lens out till we get the image. Right, tricky to get because of the ball, so I'm going to move. There you go. Right, so just starting to see the image more clearly. Okay, so that's going to be our starting point, I think. That would be a good place to start. And we can go all the way to the other end. We can take the screen all the way to the other end for our upper limit. So that's a preliminary investigation. That's where I've figured out what range of positions I'm going to put the screen in. Okay, so my starting position, my starting value of D is going to be 24 centimeters or 240 millimeters. Right, so if I turn on the lights so I can see what I'm doing. Okay, so if I zoom in. Hopefully there you can see. Okay, right, let's zoom out. Right, so we're going to start with D being 24 centimeters. Okay, so I'm going to go with millimeters. So 240 millimeters at position. Of the lens to get that exactly in focus. I think that's good. Okay. Right. This is 110 millimeters. So lens is at 110, screen is at 240. Right, let's go up to 270. Screen is now at 270. Lens is now at 85. Screen is at 270. Lens is at 85. Screen is now at 330. Lens is now at 75. Okay. Screen is now at 390. The lens is now at 73. So the lens is at 73, the screen is at 390. I'll put the screen up to 450. So the screen's now 450. 71. Screen up to 450, so 550. So the screen's now 550 millimeters. Now I need to get the lens. Lens at 67. Screen is at 550. Put the screen up to, the screen is now at 670. Now it's 65. Okay. Lens position is now at 65. Okay, right, there's a range of values of U and D. You need to get those written down, and you need to write down the corresponding values of V. So now we have values of U, V for our table to do our analysis. Okay, thank you.